Hello everyone, in this video I am going to demonstrate audio preamplifier. This amplifier is having a voltage gain of 300. I am feeding 6 millivolts audio input and I am getting 2 volts audio output. So this is the preamplifier. You can see these are the stages of the preamplifier. So basically this preamplifier has 4 stages. So this is the first stage. You can see the first transistor, the second stage, here is the third stage and here is the fourth stage. The output of the fourth stage is fed to an emitter follower. So this is an emitter follower. So whatever voltage here is present will be reflected here. This emitter follower is used for the impedance matching with the secondary device. So you can see this is the audio preamplifier. This is how the preamplifier looks like. And here you can see these are the oscilloscope probes. You can see I am going to show the response of this amplifier. I am going to show the voltage gain as well. So this preamplifier is powered by 24 volts DC power supply, and here you can see these are the biasing resistances. You can see all these are the biasing resistances and these are the coupling capacitors between the stages. You can see here, these are all the coupling capacitors. So basically these capacitors will filter the DC component and will feed the AC component to the next stage, and these capacitors are the bypass capacitors. You can see these are the bypass capacitors. So this is how the audio preamplifier looks like. This is an indication LED. This LED will be changed, will vary as per the sound. You can see here, and this is the speaker. You can see this is the speaker. I am having a high frequency speaker. This is a tweeter actually. That's why the low frequency notes are not very clear. So you can see this is how it looks like. And here is my measuring instrument. This is my oscilloscope. You can see here. So this is how it looks like, and I am feeding audio file from my cell phone. You can see this is the setup, how it is fed. So since this is not a shielded cable, this cable is picking some noise. That's why the output is coming little distorted. So this has to be enhanced in the next video. You can see here. So now let me power up the power supply and we will be observing the responses. So I am powering up the power supply. So you can see there is some noise already. So if I touch this one, you can see this noise has to reduce. So since this is not shielded cable, that's why it is picking some noise from the atmosphere. So you can see this is how it is. So if I see the oscilloscope now, let us see the oscilloscope and we will be seeing the results first without audio file. You can see here noise is present, and here you can see the input. Here you can see the input feed. You can see the input RMS on the channel 1 RMS. So this channel 1 RMS is 12 millivolts and the channel 2 is 1.93 volt. There is an amplification of the noise basically. So here you can see this is how it is. So let me play the file, we will see the response. So now I am going to play the audio file. You can see. You can see this LED status is changing with the sound. So here you can see. So now let us look into the oscilloscope. Here you can see this is the oscilloscope result. You can see. So this is the amplifier input, nearly 6 millivolt, and I am getting 2.02 volts at the output. You can see. Wait just a minute. So here you can see I am feeding 6 millivolts and I am getting 2 millivolts at the output. You can see if we divide this, it comes 300. So that is the gain of the amplifier. You can see this is the response. You can see the yellow trace is the input and the green trace is the output. And here you can see this is the circuit diagram. You can see this is the signal feed fed to this first stage. This is the first stage, 10 kilo ohm, 10 kilo ohm voltage divider, and these are the biasing resistances. Bypass capacitor feeding to the second stage, voltage divider again. Then here you can see the biasing resistors, this decoupling capacitor here. Okay, then the third stage, coming to the fourth stage, and finally here is the emitter follower. You can see this is SL100 I have used here. I forgot to write it. This is SL100. So like this, the circuit diagram is used. You can see here. So if you see here, this is the voltage gain calculation. The input voltage is nearly 6 millivolts and the output voltage is 2 volts. If we divide, the voltage gain comes 333. So say it is 300. So this is how this amplifier is wired and it is performing. So this amplifier needs some enhancement. So we will be doing it in the next videos. Thanks a lot. Thanks for watching.